quick look at the sky tonight, for tonight, July 2nd, highlighting or going forward to July 4th. For those of you who are going away on vacation, going out for a barbecue, want to look up at the night sky, what's up there, or going away on a camping trip with the family. This is the video for you. Good evening, friends. Welcome. This is Dr. James Daly of Astronomy for Change, here to take us all on a tour of the early July summer night sky. Okay, we open up our view tonight facing due south. The full moon, the moon is full tonight, sitting just over the horizon at 9 p.m. So let's run the clock ahead just a little bit and see what happens and see what the night has in store for us. It's now 10 o'clock, it's 10:30. Let's stop it right there. At 10:36 tonight, we see the moon is centrally located in Sagittarius. Let's take a look at what the ancients saw when they looked up at the sky. When they put the dots together, they connected the dots and they immortalized their culture and their mythology in the heavens. The Greeks and the ancient Greeks and Romans. This is what they saw. There's the scorpion, here's the centaur, Sagittarius, the constellations, the boundaries of the lines of the constellations, and here are their boundaries. Okay, turn this off. Zoom in on Antares. Antares is surrounded by a cloud of gas and dust. It's a red giant star, red supergiant star, highly evolved, similar to Betelgeuse, smaller than Betelgeuse, but nonetheless a supernova candidate. Like Betelgeuse, it's above 10 solar masses. Antares is about approximately 12 solar masses. What we see here, we observe in the field around Antares. The field of view, the gas and dust is consistent with stars that are high mass stars that are highly evolved. Immediately to the west of Antares is the famous globular cluster, Messier 4. M4 is visible in a pair of large binoculars. Ideally, you need at least 150 millimeter or 6-inch reflecting telescope to see it, ideally to start to resolve the brighter stars. It's interesting to note the brightest stars visible in this cluster are stars similar to Arcturus. Now you look at the distance to this object, it's 7,200 light years. It's over 10 times the distance to this globular cluster than it is to Antares. Antares is a mere 553. So this is over 10 times the distance. So the stars, the brightest stars we see here, these stars here, just the few of them here, and the brightest stars in this cluster are stars similar to Antares in their evolutionary stages. Okay, to give you a sense of scale, Antares is much closer. At least it's over 10 times closer than that globular cluster. Globular cluster is an agglomeration of at least 100,000 stars, all bound together by gravity, and represents some of the oldest objects in the universe. The stars are relics dating back to a much earlier time in the universe. Stars in those clusters generally are between 7 and 9 billion years old. The sun, by comparison, is only 4.5 billion years old. Another star to compare these brightest stars to would be the star Arcturus. Okay. Let's zoom back out. Now, this whole region of the sky is replete with all kinds of jewels in the night sky, many of them located in the constellation of Sagittarius. Over here, the teapot of Sagittarius, the famous teapot. Here's the handle of the teapot, the cap. Here's the spout of the teapot, and so forth. Represents a centaur. Again, the constellations is the mythology of the ancient Greeks and Romans immortalized in the stars, all 88 constellations. And to this day, we've honored their traditions and their mythology and their history by maintaining the constellations as they saw them in the night sky. Okay, the moon is beautifully placed. For those of you who are intrigued by the moon, tonight's a beautiful night to see the moon. It's with stellarium, a lot of properties of all these objects are readily available. We can see the moon's illumination is 99.6% right here. So that's a full moon. So every full moon, every month's full moon has a name associated with it that represents some aspect to that particular time of year in the moon. For example, last month's full moon was the strawberry moon, a time during the year when the strawberries are ripe and are going to be harvested. July is the full buck moon, July 3rd. Technically, we see this moon is 99.5% illuminated. Technically, it's full after midnight. So we're just going to say the night of July 2nd into Monday, July 3rd, the early morning hours of July 3rd, we'll have technically it's a full moon where it's 100% illuminated. Okay, so tomorrow is the full buck moon. The name full buck moon derives from the time of the year that the male deers, bucks, the antlers are in full bloom, or their peak. I also should mention that this full moon happens to be what they call a supermoon, where the moon is at its closest point in its monthly orbit around the Earth at this time, where that particular point at the full moon phase, the moon happens to be at its closest point in the lunar cycle or the lunar orbit for the month. That's why we call it a full moon, a full supermoon. So July 2nd, July 3rd, Monday, July 3rd is the full buck moon, and it's a supermoon. Okay, we call it a supermoon because it's a little bit closer and hence just a little bit bigger in size on the sky. Okay, continuing further east, the summer triangle is beginning to make its way up into the sky. It's already quite a ways up. Now it's almost 11 p.m. It's 10 minutes to 11. We have Altair, Deneb, and Vega, the summer triangle. And that particular asterism is a group of stars that is recognizable on the night sky. And we see the summer Milky Way in all its splendor. Without the full moon, we're going to turn off the atmosphere in a moment to show you what the sky would look like without the moon, without the atmosphere. An asterism is a recognizable shape on the sky, a clearly recognizable shape, not a constellation in its own right, but a grouping of stars that is highly recognizable. And in this case, it's recognized as a triangle. That's why we call it the summer triangle. Vega, Deneb, and Altair. What's interesting to note is the stars, two of these stars are relatively close. Vega's about 30 light years distant. Altair is about 40. They're comparable in brightness. Deneb, on the other hand, is about 1,200 light years distant, and it's a comparable brightness. That speaks to the power of Deneb, which is a blue-white supergiant star, another supernova candidate. Okay, so that's a kind of a lesson in what they call stellar luminosities. Just because a star looks bright in the sky doesn't mean it's necessarily intrinsically bright. Doesn't mean that it's in and of itself a powerful source of energy. Deneb's a blue-white supergiant star, would dwarf the sun and would dwarf Antares, and not so much Betelgeuse, but it's not quite as large as Betelgeuse, but it's still in its own right an enormous star, 200 or 300 times the radius of the sun, whereas Betelgeuse is about 1,000 solar radii. It's a blue-white supergiant star, a supernova candidate, just like Betelgeuse. Okay, now let's take a look, as promised, at the summer Milky Way. The problem is the summer Milky Way, even in the clearest, darkest skies, is not going to really be visible with the full moon out. The full moon is embedded right in the galactic center. Let's turn off the atmosphere and take a look at what that means. Okay, you see that? That's the center of our galaxy. We're looking 25,000 light years towards the south. What you see right here is the center of our galaxy, 25,000 light years distant. The full moon is situated right here, so that's going to wash everything out. Okay, so we won't be able to see this. The summer Milky Way is visible only really for 2.5 weeks out of a full month because of the moon. The moon basically does say, pretty much washes out the sky in terms of what we can see, some of these deep sky treasures, star clusters, some of these beautiful nebulae. It's a Latin term for cloud. Some of these objects, we need a moonless night to see it, clear, dark, moonless night in order to see them. With the moon out, which is generally 2 weeks out of the month, those objects are diminished in their splendor in terms of how we see them in the sky. Briefly though, let's put on the constellations and see what they look like. Okay. Cygnus is also known as the Northern Cross for obvious reasons. Okay. Looks like a giant cross on the sky. Okay. So let's run the clock further into the night. Not quite at 11 p.m. here. Saturn is rising, 30 minutes to midnight. Pair of binoculars, you could start to see the rings of Saturn. Now it's after midnight. The moon is, you can take a look at where the moon is. The full moon is due south at midnight. Saturn is to the east. Take a look at Saturn. And what the nice thing about Stellarium is the view you see with Stellarium is how you would see it in a telescope or a pair of binoculars. And the positioning of the moons is accurate too. Okay. Continuing further on into the night. We have a lot of the autumn constellations visible here now. Here's the Great Square in Pegasus. Andromeda, here's the Great Spiral Galaxy in Andromeda right up here. This faint patch of light on the sky. Let's take a look at it. Zoom in. This is a beautiful object in a pair of binoculars. It's a companion galaxy to ours, a cluster of galaxies known as the local group of galaxies. It's a large major spiral galaxy just like our own. These are satellite galaxies. This one here, Messier 110, and this is Messier 32 over here. Okay. This is that's Andromeda, which is attached to the Pegasus, the Great Square in Pegasus right here. Again, let's put up the constellations. You can see what this looks like. Right here. There's the Great Horse on the sky. There's Andromeda. Okay. Jupiter's rising as well. Here's Jupiter. In the east-northeast. This is almost 2 a.m. in the morning. Here's Aries. This is constellation of Aries, the Ram. These are all autumn constellations now. We're seeing the autumn because it's well after midnight, and we're going to start to see the constellations of autumn as each day progresses, as the calendar progresses through July into August and into September. The autumn constellations will start to take front and center. Right now, though, we have the beautiful constellations of summer. Okay, this is Aries, the Ram. Over here is Jupiter. Let's take a look at Jupiter. Zoom in on Jupiter. Okay, you can see the Galilean moons made famous over 400 years ago by the Italian astronomer and physicist Galileo Galilei. With his primitive telescope, he was able to see these four satellites, and from night to night he would chart their position. We would chart their change in position, and made a leap of insight and proposed that they're in orbit around Jupiter. Okay. These are the cloud belts of Jupiter. Jupiter is a gas giant planet, orbits the sun once every 12 years, and it's about not quite 5 astronomical units distant from the sun. The astronomical unit, 1 astronomical unit is the distance from the Earth to the sun. Okay, and again, this is the positions of the satellites. If you were to go out and look at Jupiter with a pair of binoculars, this is where you would see the moons. You can see the moons of Jupiter with a pair of 10 by 50 binoculars with ease. Okay, the cloud bands you need a telescope for. Okay, that's Jupiter. Let's continue the omnipresent march of time. Here's Capella, bright star in Auriga. Here's the Pleiades, the Seven Sisters. This is Taurus the Bull that's rising now. Pleiades are in Taurus the Bull. There's Uranus. You need a telescope to see Uranus. A pair of binoculars, you can see it, but you'd have to know exactly where to look. There would be a tiny blue spot on the sky. Okay, you can see the sky starting to get light. It's now almost 4:30 in the morning. Here's Aldebaran, another red giant star. Okay, here's the Seven Sisters, the Pleiades. We'll zoom in on it. Okay, this is a beautiful object to look at with a pair of binoculars or a richest field telescope, a wide field telescope. There's a breathtaking view through a wide field telescope. Even with a pair of binoculars, it's quite a stunning view. Okay, this is the early morning sky. This is almost 4:30 in the morning. As the sun sets, the first object we see out at night is Venus, followed by Mars, followed the setting sun into astronomical twilight, which is about an hour after sunset. So this is astronomical twilight. We see the stars of spring setting in the west. Over here is Virgo with Spica. The brightest star in Virgo is Spica. As we move to the east, we're going to see the beautiful stars of summer coming front and center with the beautiful full moon right there. Now, I did promise what the sky was going to look like on July 4th, so let's advance the sky 48 hours to the same point on Independence Day night, July 4th. Okay, the moon isn't risen yet. Let's advance the sky a little bit. This is 9:19 in the evening. Some of the Milky Way is coming out. It looks beautiful. It's quite nice. That's the galactic center right here. The moon will be coming up very, very soon. There it is. Rising exactly at 10:20 at night. This is known as a waning gibbous moon. Waning in phase, but not in size. Waning means to get smaller. Its phase is diminishing, but its size remains the same. And it's on its way to third quarter and eventually to a waning crescent and a new moon. A new moon begins the lunar cycle all over again. So this is the sky on the evening of July 4th, Independence Day celebrated in the United States. Okay, folks, that's the sky for early July, Independence Day weekend, 2023. This is Dr. James Daly of Astronomy for Change. Don't forget to keep looking up, and may you come to love the stars too fondly to be fearful of the night. This is Dr. Jim Daly of Astronomy for Change. May you come to love the stars too fondly to be fearful of the night. And remember, the Earth is a mote of dust floating in a sunbeam. That's reality. Everything else is just marketing. The great philosopher Plato famously said, "Astronomy compels the soul to look upward and leads us from this world to another." Astronomy for Change is a non-profit organization whose mission is to effect positive change through astronomy and science education. It is our belief that by inspiring and empowering current and future generations to become interested and engaged in astronomy and science, this positive change will be realized. If you found this video helpful and educational, please like, subscribe, and share. Also, why not consider supporting us on Patreon?
Head over to our homepage, astronomyforchange.org, and click Support Us via PayPal or Patreon, and choose a membership level suitable for you. Every little bit helps us produce the great content and further our mission. Also, why not consider becoming a member? Choose the membership link here, click it, put your name in, your first name and your email, and you'll be added to our list. You'll receive a comprehensive digest of all our videos and articles and all our great content. Joining and becoming a patron helps us grow and improve and more fully realize our mission. Thank you.